Hi, this is Pari. We will be talking about a paper from uh, Xavier and Mohammed Manan about from very weak to very strong, analyzing password strength in methods. This is a paper presentation for introduction to cyber physical security. Uh, co- um, So, uh, if you see the paper presentation, the link is provided on this slide, and then uh, we will be talking about a few major things. Now, everyone knows what a password checker is. So one of the example of a password checker is when you go into various sites and select your password for the first time when you sign up. It usually shows you various kind of restricted entries to provide in the specific to select your password, like similar to like you need to select one at least 8 letter long word with one uppercase, one lowercase, at least one digit and one special characters. So that's one of the examples. Second is we will be talking about various designs of a password checker. One of the major example of a password design requirement for password checker is like every time you enter a password, it should show you how secure your password is, and the ability to show that can be varied from a specific text message like very weak to very strong, or it can be a bar which can show different colors like uh, red for very weak and green for strong passwords. So that is one of the major example. We will be overall in the authors have kind of went over 11 different prominent web providers passwords, few of which are Apple, uh, Dropbox, Drupal, eBay, FedEx, Twitter, Skype, and Yahoo. We won't be going through every one of them, but if you are interested into the results of each one of them, you can always see each one of them on the paper itself. Um, and then next part we'll be talking about is the designs of such password checkers. One of the major drawback of pretty much most of them, other than Dropbox, is that none of them actually reveals the algorithm behind that password checkers design. So uh, authors have tried their best by reverse engineering some of them, or maybe doing it uh, various try and uh, try bases. There is also we will be going over the test mechanisms used by authors to detect the various password checkers. Uh, there are various types of password checkers, and we will go from each of them. One of the major, then we will talk about the results shown for each of the password checkers. There is a drastic variation in each of the password checker. And then the last thing we'll be talking about how often a lot of the sites have allowed users to provide the users to uh, use the weak passwords even after detection. That is one of the major weaknesses for the site. One of the major thing I want to say right now is a lot of the research that authors have done in this paper is for around the June and November 2013, and a lot of the things have been changed in the last previous 6 years. So some of the information might be outdated, uh, but we will be going over them. So as I mentioned, one of the major things that you can see is I mentioned how the password checkers kind of show uh, once you provide the password and how secure your password is by like, well, this is a site how secure my password is. It tells you if you write your password that uh, I just wrote 1 2 3 4 5 6 7 8, and it told me it can be instantly cracked because it's pretty top most used password. Well, one of the different example UX design is when you write your password, it tells you your password is really easily guessable and you need to uh, change the password. It also even shows the different colored bars depending on how your password can be cracked. How strength how the strength of your password is. One of the major point that we were talking across the whole presentation is um, how does the lot of password checkers determine the strength of the password, because it's a non-trivial task. So now going over, so each, as we said, each password checker can requires a specific set of requirements, and each of them usually has a specific set of features in it. So each password check, we will be, so authors have differentiated each password checker with a various set of character types, so char setters in uppercase, lowercase, special characters, digits, etc. Length of the password is in lot. The time that the paper was authored, uh, a lot of sites were not holding the eight character limits in their password, and they were um, kind of still using the uh, 5 words limits and etc. Uh, there were so if you there were a couple of leaked databases at that time, password databases that in 2013 that authors have also used to show this weakness. Second thing the users have uh, were gone through is the strength scale. So one of the major thing is you can always, like, the UX of a password checker can be varies drastically, as as we saw in the previous slide. It can be it can be displayed as the words like very weak, um, medium, very strong, and very strong, or it can be even just a strong, weak, medium, or strong, or lot of some of the famous uh, webs social networking sites also shows them as a bar. So it can grow as like really red as a weak password to a green, and a full bar as a strong or very strong password. Then the next thing we will be talking about is the type of where the password, the calculation for strength of the password is being calculated is done. Um, Three major, as everyone has pretty much guessed, is they can be either on the server side, client side, or a hybrid, where some of the calculations are being done at the client side, and then the password is sent on the on the server side to actually check in the blacklist, etc. We'll be talking in more detail in the next in next few slides. The next thing we'll be talking about is diversity. So each password, one of the major thing that you authors have noticed is each of 11 websites that they have checked or researched across were using a different password checker. So one of the major drawback usually it happens is one password can be considered secured in one of the sites, but it can be considered really weak on other, which can confuse the user really, thus leading into selecting a weak password maybe down the road. One of the example is password one, which is considered really weak in Dropbox, but it considered pretty strong by Yahoo. Uh, it's surprising that things have been changed. Maybe one of the reason why Yahoo's database got leaked and things like that. But let's moving on. Second, last thing that the way that authors have bifurcated their uh, password meter is by entropy and blacklist. So as a lot of the server side, or maybe in some of the client side, password checkers do converts the various patterns of a string into a specific, and gives them a specific entropy values, and then assign the runs a specific sum of mathematical um, values, and gives it a score, and the definition and the given score is then processed into some equation, and then displayed to user as a very weak to strong kind of a basis on the scale. Blacklist is pretty, as the name suggests, it's a list of passwords which are considered really weak. Like uh, they usually tend to be in the top 500 or some passwords and the variation of the passwords. So one of the major use cases, like 1 2 3 4 5 6 7 8, which is top in the top five most used passwords, where and it's really weak, so you don't want your users to select similar passwords. Things that we will talking in detail about the way that our authors have provided and gathered the test results. Um, as I mentioned in the previous slide, there are various sites like Dropbox and some similar other do Dropbox, Drupal, Microsoft, Twitter. Some of them actually uses client-side password verification. To get those information, they usually go and load up the website, and then put various breakpoints in the Firefox or Chrome and similar browsers, and then doing a trial and error method, they actually find out all the code that is being executed during a password submission, and then extracting that password and running us running a script against that snippet to gather various information, uh, how much time does that checker took across to go across the dictionary password dictionaries from the varying size from 500 to 2 million, and similar, and also getting the most importantly, getting the strength results and derivation of the password strength for all the leaked passwords. Then the second part is server-side testing. This is pretty difficult for a lot of reasons, as none of the none of the none of the websites service providers never provided the information about which algorithm or anything, information about algorithm, HTTP call, and what are the parameters that they are sending during the execution. So authors put a breakpoint during AJAX snippets, which is what calls uh, calls HTTP calls from JavaScript usually, and then gathering and then debugging and monitoring each AJAX request and their parameters, and then manually creating a script using curl with a keep alive connection to send multiple passwords at a time, to reduce use authors also had used various mechanisms to actually avoid the server-side blocking during testing large dictionaries, like for 2 million data sets and things like that. Um, Our last kind of testing is the hybrid. This can be really tricky with the introduction of codes headers, which is there to prevent the cross-site scripting. So to the users, what they did, to authors, what they did was they tried to uh, run the given password in the specific client side, and and then force the client to go through a PHP proxy which usually modifies or adds the code's header to make the request acceptable to a server side. That way, the client server does not deny or blacklist the IP the users are trying. So now, moving to the test dictionaries. So the authors kind of used dictionaries from the various sizes from 500, which is top 500 passwords, to 2 million, which can be RY5, uh, or it can be called as a ROCU, which is one of the leaked passwords dictionary. They also provided, they also used two different languages to include variation in the passwords, as even though the major population of the world uses English to select their passwords, there can be a lot more variation due to Spanish, French, Japanese, and various languages, and a lot of the websites usually considers non Latin characters, mostly as symbols and digits. Then they also include a technique called mangling. So mangling is really uh, basic techniques where people try to put a different uh, put a small variation, like password becomes password one, password with a capital P, or reverse of a password. Include even a password can be also you can append or prepend a specific characters like star or exclamation mark, and then you can introduce multiple variations. So one of the major example is Jack the Ripper is one of the tools which the authors used to apply various kind of mangling rules. Instead of developing a new or extra rules, they just stick with the default rules, and each top 100 password can be provided into at least 20 to 40 different kind of similar passwords. Then the last techniques they have used is lit transformation, where they where authors kind of mapped characters to a lit transform. So E becomes 3, S becomes 5, or dollar sign, A becomes at the rate, or it can be even become a 4, etc. I think that one of the this slide kind of shows the different services that the authors had used. You can see in here is that a lot of the services like Dropbox, Yahoo, Twitter, Microsoft use the client-side verification, and they go to from scale, and they have various limits ranging from 6 to few thousand characters. Um, they also forces selected char set, which can increase your security from uh, drastically, and then depending on whatever the result that you have provided, it can also either enforce the result, as in like Dropbox will allow a very big password, but meanwhile, one of the really interesting result is FedEx, where FedEx security was one of the most uh, strict in certain senses. It will actually require you to have a medium strength password with minimum 8 characters, including at least one lower, upper, and digital digit, uh, which is surprising for the amount of information it holds compared to a lot of others, where some sites like PayPal or Google can store your payment history, while FedEx usually holds your addresses. We will talk more detail in the later. Um, the way that the major way that authors have evaluated each meter using various types like algorithm, which kind of algorithm the given server or client password meter is using. But as I mentioned earlier, other than Dropbox, none of the algorithms were made actually open source, so they were and the design choices were kept private. So client had tried their best by using trial and error mechanism to guess those algorithms. Second is the usage of user information, similar to username, password, birth of date, first name, last name, all those email address, and similar information in the password, and assigning them lower points. not including them at all, strength of each password evaluation, weakness, or they will be going over some small pieces. Dropbox. This was only password meter which had open source, which had made its own password meters design and algorithm open source, which is called ZX CVBN, um, which, as a short answer, a short way of describing it, it will decomposes the password string into various small patterns, and each pattern is assigned a various is assigned an entropy, and how it calculates entropy we'll check in the later in few minutes. But and there will be multiple patterns coming out of that password, can be from really known word to a random string, and if it's a known word it will be assigning to a lowest really low entropy, and some of each lowest entropy is then feed to a formula which calculate that if a attacker guesses the password, uh, uh, um, if the attacker can guess like 10,000 passwords in a second, um, it also alternatively it also calculates that if a attacker can guess the password, if attacker can guess 100 password per computer per 100 computer per second, how long it will take to crack that password. And given that range, it assigns a score, and depending on the score, it shows very weak to very strong. So one of the example, let's going back to the selection of entropy is uh, one of the major example is if you have a password called password1, then it would be assigned really low score because password is a well-known password, and which is really top on the known password list, thus giving a really low entropy. And then the one is pretty known word, and given that it also assigns low score, thus giving it to very low information. It also includes, so one of next thing is the user information. Every time a user adds its username, first name, or email addresses, or any variation as like leet code, mangling, and they are assigned really low weak entropy. Uh, and each weak entropy is gonna keep a dent in the selection of a password, thus making the password really weak and down the road. Strength, and to be honest, we will see in the later end of the slides that uh, Dropbox really had a pretty well in the password checking. One of few weaknesses, as mentioned, is it doesn't compare the passwords to any other dictionary other than English. Thus, any passwords which are just translation of a password since various known passwords uh, are scored really higher. It also is not able to detect the obscure patterns like 1A, 2B, 3C, 4D, which is pretty known if a user can guess. Um, Similar to it is pretty hard coded algorithm, thus ignoring the trending passwords like Dolce and Gabbana, which was trending at the time of the um, trending well-known Italian luxury brand at the time of paper uh, writ, or when the author wrote the papers. And then the author of the papers also found the small bug where the uppercasing the first name or the last name is getting ignored in the low entropy scoring mechanism. we'll be talking about is eBay. Uh, eBay is also the server side where before it even signs the password, it actually checks across eight letters and eight letter words, and at least it requires two char sets, either from a lower upper digit or special characters. It also gives the score number by the unique types of char sets being used. So if you just use a single char set, it's invalid. Two gives weak, three gives strong, and four gives very well, very good or great. It also considers username and email during the checking of password and rejects any password if contains any mangling passwords, a pattern of a username or email. Weaknesses, one of the major weaknesses for eBay is any passwords with a lead code transformation is considered really strong. Strong. Apple is one of the first one to implement the hybrid kind of password checking, where it actually checks the client side checks strict requirement of eight characters, one uppercase, one lowercase, one digit, or no more than two consecutive identical characters. And then the password is sent to on the server side to do a blacklist validation against the blacklisted database. A few major inf information that users have found is mangled username is also considered blacklisted, and it wasn't allowed to use users isn't allowed to use any mangled username in the password. Strength and weaknesses are strength and weaknesses can be defined as it also does a dynamic evaluation while the typing, so user can get the feedback right away. Uh, Same way, it had really comprehensive and dynamically updated blacklist that according to the authors. Um, Similarly, if and it also weren't able to find any consecutive patterns. If you write the same word twice, it can be considered really strong, even though the mangling. If you do a reverse mangling of a given repetitive word, like shown here as a password, uh, it is a well-known password and it is blacklisted. Uh, One of the really drawbacks that user kind authors kind of shown was that the response times was varying really well, depending from the few minutes to few seconds to FedEx. To be honest, the authors were really surprised, as I mentioned before, by um, it was really strong compared to any other checkers. It was pretty simple checker with the inbuilt embedded almost 500 word dictionary, and it does various split code transformations, and it has pretty stringy requirement as mentioned before. And similar to all others, it also does uh, reverse transformation of a lit code, and uh, it can be defeated by extra characters in the known password. So few analysis out of the whole multiple papers that the authors kind of mentioned were um, that the meters heterogeneous inconsistency, where same password can, as I mentioned in the start of a presentation, the same password can be considered really weak to extremely strong by different meters, which can cause a confusion between users. Uh, Thus forcing user to choose a weak password for certain times. Targeted dictionaries, where users usually used to choose uh, it can be varying depending on the trending cycles and etc. It can be also outdated down the road. Comparison, uh, one of we will talk and the slide is shown in the next few slides about the comparison of each password checkers. One of the things that I mentioned before, that it does a lot of the password checker doesn't consider any non-latent code characters. And either they disallow such characters or they choose maps as a symbol, and then implications of design choices as each of the password checker is mostly, other than Dropbox, is a black box, thus providing security by obscurity, which is really bad policy as we learned from the lecture of the courses. Then same way, users once given a stringent bypass, user usually trying to avoid the mangling in the passwords and thus choosing really weak passwords, same as the passwords or policies can are being differed across each of the websites drastically, as we mentioned in the previous slides, where some certain sites just forces user to use at least three char sets in the selection of password, while other does not. So users can choose really weak password really easily. Because that we should a lot of password meters does not consider the consider the implication of offline and online attacks, where offline attacks can be you use where attacker can crack thousands and millions of passwords hashes and can calculate millions of hashes in a second using big GPU farms and stuff, while online attacks where can be mitigated by having if captcha or block rate limiting the number max retries of password. Password leaks. A lot of even the user uses extremely strong password, if one leak it is considered really weak, as it is it is available in various known dictionaries like Jack the Ripper, etc. Passphrases where users tend to remember the passwords. They tend to choose uh, various known passphrases like their birth date, social security numbers, and such information. But a lot of time due to the lack of those information, website cannot put those in, cannot consider those in between the password checker, but the attacker who is doing a social engineering can be considering such information. The few suggestions provided by authors were once the use inherent patterns in the user choices, use the global universal adaptation of password policies, where each site should have mostly used to use same kind of policy, similar to have at least one of at least three char cases, eight letter capital words. Also, one of the suggestions that I'm going to mention is using a good password storage mechanism like LastPass or OnePass or KeePass, which allows you to choose long, really strong, randomized password and password for each websites or each services. And a lot of times each of the websites should consider the exposure of the leaked databases and force user not to choose similar passwords and include the leaked passwords into their black conclusion. There has been various adaptation of the semantically aware techniques, which is usually being used to actually track the passwords by the attackers. This can be used as a proactive measures where user are forced to no, unavailable forced to not choose semantically aware passwords, forcing user in a way that they prefer to choose strong password over the weak passwords. And the last thing can be one of the major thing that authors suggested that every time a user types the letter, similar to Apple, the password meter should be updated, thus providing forcing user to go over the stronger selection of a password. And one of the suggestion by authors and me, even including me, is to do not try to reinvent a new password meter. Instead just use a well-known open source password meter implementation like ZXC, VBN, or try to extend them. But even in the extension, you need to be really careful. That will